Functions. Within a contract, we define functions that can be called by an EOA transaction or another contract. In our faucet example, we have two functions, withdraw and the fallback function. The syntax we use to declare a function in Solidity is as follows. Function, function name, open parentheses, parameters, close parentheses, public or private or internal or external, pure or constant or view or payable, modifiers, returns, return types. Let's look at each of these components. Function name. The name of the function which is used to call the function in a transaction, from another contract, or even from within the same contract. One function in each contract may be defined without a name, in which case it is the fallback function, which is called when no other function is named. The fallback function cannot have any arguments or return anything. Parameters. Following the name, we specify the arguments that must be passed to the function, with their names and types. In our faucet example, we define uint withdraw amount as the only arguments to the withdraw function. The next set of keywords, public, private, internal, external, specify the function's visibility. Public. Public is the default. Such functions can be called by other contracts or EOA transactions, or from within the contract. In our faucet example, both functions are defined as public. External. External functions are like public functions, except they cannot be called from within the contract unless explicitly prefixed with the keyword this. Internal. Internal functions are only accessible from within the contract. They cannot be called by another contract or EOA transaction. They can be called by derived contracts. In other words, those that inherit this one. Private. Private functions are like internal functions but cannot be called by derived contracts. Keep in mind that the terms internal and private are somewhat misleading. Any function or data inside a contract is always visible on the public blockchain, meaning that anyone can see the code or data. The keywords described here only affect how and when a function can be called. The second set of keywords, pure, constant, view, payable, affects the behavior of the function. Constant or view. A function marked as a view promises not to modify any state. The term constant is an alias for view that will be deprecated in a future release. At this time, the compiler does not enforce the view modifier, only producing a warning. But this is expected to become an enforced keyword in version 0.5 of Solidity. Pure. A pure function is one that neither reads nor writes any variable in storage. It can only operate on arguments and return data, without reference to any stored data. Pure functions are intended to encourage declarative style programming without side effects or state. Payable. A payable function is one that can accept incoming payments. Function not declared as payable will reject incoming payments. There are two exceptions, due to design decisions in the EVM. Coin-based payments and self-destruct inheritance will be paid even if the fallback function is not declared as payable. But this makes sense because code execution is not part of those payments anyway. As you can see in our faucet example, we have one payable function, which is the only function that can receive incoming payments. Contract constructor and self-destruct. This is a special function that is only used once. When a contract is created, it also runs the constructor function if one exists, to initialize the state of the contract. The constructor is run in the same transaction as the contract creation. The constructor function is optional. You will notice our faucet example doesn't have one. Constructors can be specified in two ways, up to and including in Solidity version 0.4.21. The constructor is a function whose name matches the name of the contract, as you can see here. Contract, me contract, open curly brace. Function, me contract, with no argument, open curly brace. Comment, this is the constructor, close curly brace, close curly brace. The difficulty with this format is that if the contract name is changed and the constructor function name is not changed, it is no longer a constructor. Likewise, if there is an accidental typo in the naming of the contract and/or constructor, the function is again no longer a constructor. This can cause some pretty nasty, unexpected, and difficult to find bugs. Imagine, for example, if the constructor is setting the owner of the contract for purposes of control. If the function is not actually the constructor because of a naming error, not only will the owner be left unset at the time of contract creation, but the function may also be deployed as a permanent and callable part of the contract, like a normal function, allowing any third party to hijack the contract and become the owner of the contract creation. To address the potential problems with constructor functions being based on having an identical name as the contract, Solidity version 0.4.22 introduced a constructor keyword that operates like a constructor function, but does not have a name. Renaming the contract does not affect the constructor at all. Also, it is easier to identify which function is the constructor. It looks like this. Pragma caret 0.4.22. Contract MD contract, open brace. Constructor with no argument. Open curly brace, close curly brace, close curly brace. To summarize, a contract's life cycle starts with a creation transaction from an EOA or contract account. If there is a constructor, it is executed as part of contract creation to initialize the state of the contract as it is being created and is then discarded. The other end of the contract's life cycle is contract destruction. Contracts are destroyed by a special EVM opcode called self-destruct. It used to be called suicide, but that name was deprecated due to the negative associations of the word. In Solidity, this opcode is exposed as a high-level built-in function called self-destruct, which takes one argument, the address to receive any Ether balance remaining in the contract account. It looks like this. Self-destruct of address recipient. Note that you must explicitly add this command to your contract if you want it to be deletable. This is the only way a contract can be deleted, and it is not present by default. In this way, users of a contract who might rely on a contract being there forever can be certain that a contract can't be deleted if it doesn't contain a self-destruct opcode. Adding a constructor and self-destruct to our faucet example. The faucet example contract we introduced in the intro chapter does not have any constructor or self-destruct functions. It is an eternal contract that cannot be deleted. Let's change that by adding a constructor and self-destruct function. We probably want self-destruct to be callable only by the EOA that originally created the contract. By convention, this is usually stored in an address variable called owner. Our constructor sets the owner variable, and the self-destruct function will first check that the owner called it directly. First, our constructor. Pragma Solidity caret 0.4.22. Contract, faucet, address, owner. Constructor, owner equals message.sender. We have changed the Pragma directive to specify version 0.4.22 as the minimum version for this example, as we are using the new constructor keyword introduced in version 0.4.22 of Solidity. Our contract now has an address type variable named owner. The name owner is not special in any way. We could call this address variable potato and still use it in the same way. The name owner simply makes its purpose clear. Next, our constructor, which runs as part of the contract creation transaction, assigns the address from message.sender to the owner variable. We use message.sender in the withdrawal function to identify the initiator of the withdrawal request. In the constructor, however, the message.sender is the EOA or contract address that initiated contract creation. We know this is the case because this is a constructor function. It only runs once, during contract creation. Now we can add a function to destroy the contract. We need to make sure that only the owner can run this function, so we will use a require statement to control access. Here's how it will look. Code commands, contract destructor. Function, destroy with no argument. Public, open curly brace. Require, message.sender equals owner. self-destruct of owner. If anyone calls this destroy function from an address other than owner, it will fail. But if the same address stored in owner by the constructor calls it, the contract will self-destruct and send any remaining balance to the owner address. Note that we did not use the unsafe transaction.origin to determine whether the owner wished to destroy the contract. Using transaction.origin would allow malign contracts to destroy your contract without your permission.